Hey professor, this is my circuit for problem 1, the DFF circuit. So now we can look at the schematic. So here we can see that we start out with both inputs being 0, and so our output Q is 0 and our output Q1 or Q bar is 1. And then at about 0.4 microseconds we see that input 1, which is data, that jumps up to 1, but because data is 1 and clock is 0, our outputs Q and Q bar stay the same. But now since data is at 1 and right here at 5 microseconds clock becomes 1, then we see the change in our outputs, and so that's why we see Q become 1 and Q bar become 0. We continue down this way to 1 microsecond. Sorry, the other one was 0.5. I don't know if I said that. We come down to 1 microsecond. Because data stays at 1 but clock changes, our outputs don't change. But now that clock is 0, when we come to 1.1 microseconds, we see that data becomes 0. And so since it's only one change, our outputs still stay the same. Then we come to 1.5, and we see that since data is at 0, and we get a clock change, of 1, therefore our Q becomes 0, and so therefore both our outputs change based on that, I guess, requirement. I don't know what the word would be. It's late. We see no change in our outputs as clock stays 1 and data jumps to 1. And then data stays at 1 and clock goes to 0, and our outputs Q and Q bar still don't change. I'll zoom out. There we go. Coming over here to 2.5 microseconds, we see clock jump to 1, but D stays at 0. And so therefore our Q still stays at 0, and we see it drop back down, and everything stays the same. And then here our data jumps up to 1, and then our clock jumps to 1, and because our clock both have jumped to 1, then we see the change in Q and Q bar, where Q goes to 1 and Q bar goes to 0.